All right, let's talk about the exact difference between getting a B and scoring that coveted A star in IGCSE Physics. Seriously, the gap between those grades often comes down to mastering these exact concepts we're about to cover. So we're going to look directly at the examiner reports today to make absolutely sure you secured those top grade boundaries.
Look at this comparison. It's honestly painful to see how many students lose crucial marks right out of the gate just by confusing cause and effect. On the left, we've got your standard, flawed answer. It's basically just a list of facts, like saying an object moves, and hey, it has force, but it completely fails to link them together. The A-star approach on the right, though, it perfectly demonstrates precise causal relationships. It explicitly shows exactly how a resultant force directly causes an acceleration. That connection is everything.
Now, to grab those top marks, we absolutely have to nail the foundational definitions. We're talking scalars and vectors. A scalar quantity, that is strictly defined by its magnitude. It's just the size, nothing else. But a vector quantity, it possesses both magnitude and direction. I know, it sounds super simple, right? But think about it. If you calculate a vector and forget to state its compass direction, your answer is fundamentally incomplete. You're leaving points on the table.
And here is a massive, massive clue straight from the Cambridge Principal Examiner. Past papers reveal that candidates consistently confuse key terminology. You literally have to dodge this trap. The secret? Always define your terms clearly at the very start of a long-form answer. It signals to the examiner that your foundation is rock solid before you even jump into the complex calculations. It's like building trust right from sentence one.
Okay, let's lock this in with a mental trick so you never, ever mix these up again. When you think of scalars, things like distance, mass, energy, or temperature, just imagine a number. Picture a thermometer or stopwatch in your head. But for vectors, stuff like weight, velocity, or gravitational field strength, I want you to visualize a bright red arrow firmly attached to them. Weight is a force pulling downwards, velocity is speed heading in a very specific direction. See those arrows in your mind and you won't lose the marks.
So, speaking of arrows, what happens when they meet? Specifically, what is the ultimate examiner clue for determining the resultant of two vectors at right angles? Well, in just a sec, I'm going to reveal the exact clue that completely changes how you calculate this. But first, you need the step-by-step strategy that makes that clue obvious. Because honestly, jumping in blindly is exactly why so many students just freeze halfway through a tough question.
To avoid that freeze, you need a bulletproof framework. Meet the four-step method mark strategy. Examiners actually award points for your systematic processing. So, Step 1, identify the core concept. Step 2, extract the exact data from the prompt. Step 3, apply your scientific reasoning. And finally, Step 4, present it all using precise examiner wording. Following this sequence literally guarantees you pick up method marks, even if your final calculator math is slightly off.
All right, let's put this into practice. We've got a classic Cambridge-style challenge scenario here, where you need to extract data from a table to find a resultant force. I want you to pause for a second and really predict your approach for this exact problem. What's your very first move? Seriously, think about how you would map out your reasoning on those blank lines of the exam paper right now.
See how much of a game changer the right wording is? That vague response on the left completely misses the mark because it's just reciting generic textbook facts without any specific context. But look at the red pen corrections on the right. By using appropriate terminology, setting up the right mathematical format, and actually directly addressing the specific scenario they gave you, you instantly elevate your answer straight into that A-star band.
So, we need to hardwire these top 3 principal examiner warnings into your brain so you avoid these known traps. Number 1, confusing cause and effect. Don't do it. Number 2, skipping clear notation and losing those easy formatting marks. And crucially, number 3, giving answers that ignore the context. Look, if the question is asking about gravity on a specific planet, a generic textbook definition just won't cut it.
Okay, circling back to that mystery from earlier. How exactly do we tackle those right angle vectors? Well, the clue is almost always buried in the word determine. When asked to determine a resultant, you need to draw a vector triangle from your given perpendicular magnitudes. Solve systematically using Pythagoras for the size, and then, and this is the vital check everyone forgets, use trigonometry to find the exact angle. Because remember, a resultant vector without an angle is literally just a scalar wearing a disguise.
Let's do a quick-fire recap to make sure your analytical depth always triumphs over superficial breadth. First, master and deploy your specific definitions early. Second, always use that 4-step concept: data, reasoning,
wording strategy to secure every single working mark. And third, relentlessly evaluate your final answer. Ask yourself, does my vector have both a realistic magnitude and a clear direction?
But all this leaves us with a pretty massive unresolved mystery. Knowing the theory perfectly on paper is one thing, but how do these vector frameworks actually apply when you're designing a real practical investigation? Because proving it through real data analysis is where the ultimate grade boundaries are truly decided. The next clue to securing full marks is waiting in our follow-up explainer, so make sure to subscribe to AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Keep learning systematically, and I'll catch you next time.